Hi friends, welcome to the NPTEL course on entrepreneurship. In the previous lecture, we concentrated on startup development methodology, but in terms of digital platforms. Four of them were discussed. In today's special lecture, we will discuss development of solar charger for mobiles as a product-driven startup opportunity. This is an IITM DOMS MBA entrepreneurship course project. Student credits are due to Neha George, Potluri Sahas Chaudhary, Sahana V, and Sia Das. The premise is that cellular phones are an indispensable part of the contemporary human life. Any cellular phone is only as good as the battery charge it has. While modern cellular phones promise at least 24-hour battery life, the actual performance tends to be lower. And in places not having electricity or having frequent power outages, electricity is not available as required, and electric battery charges are of no avail. Therefore, a solar charger for cellular phones would be an important assurance to people with high cell phone usage. It represents an interesting startup opportunity. The team looked at the opportunity and came up with the following problem identification. Need for a device to provide continuous charging for cell phones while traveling or staying outdoors. Need for a device that can be charged in villages and areas with no or uneven access to power. Need for a portable and lightweight charging device. Need to shift to clean resource such as solar power to protect the environment. Solution has been defined in terms of the following three requirements. It should be a solar powered device that can charge the cell phone. It should be an ergonomic product that can be carried anywhere the individual travels. There should be inbuilt storage capability that provides quick charge when people are outdoors. This is a technology driven project. As you can see from now onwards, you will find that there is a lot of technology that is involved in conceptualizing this project and developing as well as executing it. There are several categories of light, as we are aware. One is the natural light, sunlight. Second is the artificial light, and within artificial light we have different light sources such as LED, fluorescent and incandescent. Within solar cells we have first generation solar cells, second generation solar cells and third generation solar cells. Out of these, as the generation progresses, the solar cells also have been progressing in terms of energy absorption and energy density of the cells. Today's materials comprise crystalline silicon, which does not perform as well under the electric lamps as it does beneath the blazing sun. So what is the technology that could be utilized? There are two types of alternatives. One is perovskite solar cells, we will call it PSC. It is low cost, easy to produce, durable and stable. The other is CIGS, where the active substance is in powder form. It offers more options. This team, after a thorough review of the technologies that are available, proposed the following technology. CIGS perovskite version. The P solar cell in the CIGS P version can convert the light in the visible part of the solar spectrum into electricity. The CIGS solar cell can further absorb the light in the near infrared spectrum that penetrates the perovskite solar cell. So what is the difference between crystalline solar, which we are used to, and CIGS solar? There are a number of factors which determine the effectiveness of technology. Yearly yield, shadow effect, CO2, element usage, flexibility, microcracks, durability, lifetime, temperature impact, efficiency, particularly in summer, weight, typical warranty and looks. When you look at it, you will find that CIGS solar has got certain advantages which are appropriate for the project we have in mind. They did a structural analysis of various companies that are working in this field. There have been some Indian companies and there are primarily Chinese companies which are providing these kinds of chargers, and the annual turnover varies between 1.5 crore to 10 crores to 25 crores. It is not huge sum, but the team concluded that there is possibility to drive this up provided the technology is harnessed in the right manner. The solar PV segment dominated the market share in 2019 and is expected to be the largest segment during the forecast period because of the supportive government policies to penetrate clean energy generation in the country's energy mix. As we are aware, the Government of India has taken several initiatives with the Ministry of New and Renewable Energy, drafting plans, putting out tenders, and awarding contracts. This is expected to drive the market during the forecast period. So, the Indian solar energy market in the overall is expanding and provides the necessary market perspective. There are several solar charger products that are available already. As you can see, some are good looking, some are flashy, and some are clunky. Some of the products are Anchor 21, Nectec 21 watt solar charger, and so on. The team has studied the specifications of the various solar chargers that are available in the market and felt that they could develop a product which is slimmer, sleeker, and as efficient. But then before launching into the project development, they wanted to understand what are the competitive forces that are functioning in this particular industry. So they looked at the threat of new entrants, which they felt was actually high because the government is encouraging development of the solar industry by providing subsidies. There are no entry or exit barriers due to open policy. Therefore, unless the company has a first mover advantage, the startup would face a lot of competition. Would there be bargaining power of customers? It would be, but to a medium degree, because there are alternative modes of charging and development of similar products cannot be ruled out. Therefore, there could be an increase in the bargaining power of customers, although the first move advantage may confer some competitive positioning for the product. Will there be substitutes possible? Because there would be a lot of alternatives for charging that will be developed from time to time, and solar mobile chargers and power banks are already established alternatives. The existing manufacturers may fine-tune their products to be on par or better than the proposed startup. Therefore, there is a cognizant need to counter the threat of substitutes with superior technology and superior design. Will there be threat of suppliers? Will the power of suppliers be high? The answer is yes, because the supply of solar panels in the world is governed by only a few firms. But the panel manufacturing industry is inundated with excess capacity and sunken cost. Therefore, there will be competition as well. So, what is the target market this startup could look at? Regular travelers, power bank users. This could be an alternative to a bulky power bank which they need to carry. Low power access customers, that is customers who do not have continuous and regular supply. And it is also open for environmentally conscious customers to have a solar charger. 70% plus consumers are already changing their purchase preferences based on sustainability. So if a solar charger is developed not only for mobile phone but for several other smart devices, there is always a possibility that the startup would have a good starting point. The team applied design thinking for this project. They tried to empathize with customers, and based on the research with their own counterparts and peers, they found that the issue of phone running out of charge is common. The alternative power bank available in the market are heavy and require charging beforehand. Moreover, not everybody would be wanting to afford a power bank. Second, in the design phase, the requirement for a lightweight device that provides power storage to charge phones in the absence of DC power source has been felt. And ideation is in terms of a solar back case as a replacement for traditional phone cases which can hold the phone while charging it. That is, there is no separate solar charger per se. The back case of the cell phone itself could be used as a charger. The solar module can be removed and used with any phone just by changing the back case. That is the result of the design thinking approach. Empathization phase. When does the phone run out of charge? When outside and when there is no option available to charge the phones. Customers need a charger that has better features than a power bank. And what are the limitations of the power bank? There is a need to charge the power bank prior to usage on the cell phone. There is limited power storage capacity. It is an extra product to carry, all said and done. Expensive, not ergonomic, and it has less lifetime. Given these limitations of power bank, if we are able to have a charger which is encased within the back panel of a cellular phone, it could be a possible winner. So they defined the solution in terms of the following parameters. A, it should have continuous charging capability. B, it should be convenient to use. C, it should be lightweight and thin. D, it should have high durability. E, it should be portable. F, it should be ergonomic, that is of good design. G, it should be environment friendly. H, it should have capability to charge under the sunlight as well as under the artificial light. And finally, it should have enough storage capacity. So when the ideation has been done, various alternatives were considered, and finally the short list have been in terms of the following. 1. A back panel that can hold the phone. It would be portable and lightweight. It would have minimum possible storage capacity. It will be easy to use, LED light to indicate charging percentage. It could be durable, waterproof, scratch proof and impact resistant, and with a replaceable battery it could be environmental friendly. So that is the short list of features that came out of the ideation phase. So when you look at the market analysis, there are different types of products. If you have a box charger, it has a high capacity storage. It is a generic design for all models. It is difficult to carry, need additional back panels for phone and need for longer cable. If you look at a solar wrap, the advantage is one of large surface area, hence charging is faster, but the disadvantages are that it is difficult to use the phone while charging. It needs additional back panel for phone and it is difficult to carry. If you look at a phone with adjustable border envelope, the advantages are that it can be used along with the phone case. It is easy to carry. The elastic itself can get damaged, so it's a disadvantage, and the design implementation for each model is difficult. If you have a back panel as proposed by the team, it is easy to carry and there is no need to buy additional back panel for phone. The disadvantages, however, are slow charging and the model specific design is a bit difficult. So considering these alternatives that are available, the team felt that the back panel design is ideal to be looked at. So for the back panel, the strengths were perceived in terms of high energy conversion efficiency. It will be portable and environment friendly. It will have the ability to use artificial light as well. Components can be reusable and there would be warranty and customer care. As far as the weaknesses for a solar charger are concerned, it is a newly established product and there is lack of visibility. Slightly large initial setup cost will be there and other raw material costs also could be high. There could be cheaper alternatives, especially imported from China, that could be competition. From the point of view of opportunities, clearly there is a growing popularity of solar energy. There is an increasing usage of portable products. There is also an increase in the environmentally conscious consumers. Therefore, there could be market demand that is supported by these kinds of mandatory steps as well as responsibility towards environment which people are now developing. The risks or threats are in terms of the government subsidies and tax incentives leading to increased competition, and the established companies, for example Samsung or Huawei, setting up companies to launch solar panels. That is a clear threat. So the final problem and solution have been as follows. After conducting the thorough research, the team said that the cellular phone and power bank users are certainly facing difficulties in charging their mobiles when they are outside or away from a power source. And this problem becomes more as the battery life gets lower because of the consistent usage or lot of gaming applications, or by the sheer age of the phone. And the power banks which are there come with a limited capacity and need to be charged also beforehand to use. They are not very durable and environment friendly. That is the problem. The final solution is that we should have a solar charger with the capability to charge continuously and store with minimal capacity. Since the storage capacity is less, it will make the charger lighter and easy to handle. The charger can also be used as a back case, thereby making it ergonomic and portable. The latest technology of solar cells will make it efficient and robust, while the simple electronics of the charger make it affordable and maintenance free. Overall, the product should offer a combination of sustainability and quality. So that is the final solution definition. So the team unveiled the product image and logo, which looks classy. It's called Mivon Solar Mobile Charger. This is the prototype design. You can appreciate from this that if you want to develop a startup based on product configuration, you need to have certain engineering skill and an engineering aptitude. So you design a back panel, you design a solar module, you position the charging port, and you make it sleek and compatible with the phone. There will also be a bottom view which indicates battery level indicator and an on-off switch. We need to specify the specifications for the solar charger. We need to have a battery indicator that indicates the level of charge. You need to deploy the right kind of solar charging. Perovskite CIGS technology with 30% conversion efficiency has been identified, and it will have a 2000 mAh lithium polymer battery which will have 60% of phone capacity. Thickness has been designed as 10 to 12 mm at the weight as 100 to 120 gram. You should get fully charged in 3 to 5 hours. Back panel can be designed based on the design of phone. The output port will be 5 volts 2.4 amperes kind of output port, and there will be a 9-layer circuit protection to protect devices from overheating. These are the solar charger specifications. To manufacture this solar charger, you need components. The first is the battery charging module. Second is the solar panel PCIGS type. You need lithium polymer battery. You need a switch, connecting wire, step-up voltage converter, battery level indicator, and a USB cable. So how do you start this work? For that, first you should have system architecture. When you start capturing power, you capture it from two sources: the solar source, the artificial light. Together they charge the battery, and the battery, which is lithium polymer battery, will be boosted by a DC-DC boost converter, and it goes to the USB output, and then the charging mechanism starts. So this is the circuit diagram for the solar charger. How does this work? Solar energy is the conversion of sunlight into usable energy forms. Solar photovoltaics PV, solar thermal electricity, and solar heating and cooling are all well established solar technologies. These battery chargers don't directly charge the lithium ion battery in the cell phone. Instead, they usually charge an internal rechargeable battery which is charged through the solar modules, and their charge is then redistributed to the gadget so that an external electrical source is not required. The first method was the photovoltaic cell created by researchers at Bell Laboratories as early as in 1954. Since then, solar cells have evolved from transforming sunlight into usable electricity for huge expensive space equipment to more down-to-earth devices like battery chargers. The first step in this whole process is creating an imbalance between positively charged and negatively charged particles in the technology used. This imbalance, which is created, creates an electrical field. When photons strike the material, the electrical field pushes the electrons towards the front of the solar cell, creating a negatively charged side. The protons that are left behind on the other side of the cell surface create a positive charge. When these two sides are connected using an indirect circuit like the terminals of a solar battery charger, the electrons flow into the load and create electricity. So this is the electrical circuit working that is at the back of the solar charger idea. So this is the typical circuit diagram from the solar panel to the battery charger to the voltage boost converter and finally to electricity development and storage. So how do you design a solar charger? We know that the screen sizes of phones are in various gradations. It ranges from 4.5 to 6.5 inches, and today we also have 6.7 inch phones. The width, height and depth vary from 69 millimeters to 77 millimeters, 132 millimeters to 162 millimeters, and 10.3 millimeters to as low as 7 millimeters. The battery capacity accordingly varies from 2050 mAh to 6000 mAh. The higher the screen size and the higher the processor capability of a cell phone, you also need a higher battery capacity to reduce the slide down in the battery capacity due to usage during the day. So the solar module has been designed in this particular format with approximate placement of the battery, voltage booster, battery level indicator and battery charger. Now the next step is to understand the costing for the components. So cost per component was arrived at by the team by investigating the global supply sources as well as the Indian supply sources and arriving at a total component cost for the project. I have not given those costs here. And the vendor manufacturing and assembly research also has been done. Who manufactures lithium polymer battery charger? Who manufactures solar panel, particularly the perovskite CIGS. Some of them are US based or Australia based, and the batteries are also Japan based or Michigan based, whereas simpler components such as voltage converter, battery level indicator, connecting wires, USB cables could be sourced in India. So that's how the global supply chain is identified and put into place. Once you get all these items and components, you need to do the soldering. After obtaining the equipment, the process of soldering can be done at the workplace for prototype development. Then you go to an injection molding facility. The solar module covering will be done at a plastic product manufacturing unit using an injection molding machine. The proof of concept rests on three factors. One, technological feasibility. Second, economic feasibility. And third, environmental feasibility. The technological feasibility is that it provides faster charging capacity. The used voltage output intensifies the output power voltage and helps in better charging. There will be minimum storage capacity so that the phone can be charged while using it. Solar charger functions not only under sun rays but also under artificial light. Charging time is based on intensity of life and it is adjustable based on the phone model. All these parameters are tested in actual practice. Then the economic feasibility comes. Expensive power banks have shorter durability of 3 to 4 years, while solar power chargers, which have nominal price, have much longevity. Solar power banks are economically feasible and makes customers' life easy. And the entire solar mobile charger is recyclable as it is made in modular design, and it will be a good buy for all environmentally conscious customers. So quality testing is done in terms of voltage efficiency test, testing the on-off switch button, waterproof splash proof test, and overheating test, which is done to check the effectiveness of circuit protection layer. There would also be an impact strength test. So on the right side there is a description of how the quality testing is carried out and how the charge efficiency is identified. The charge discharge time is also identified, and the charging time for the phone also is checked to evaluate the fast charging capability of the solar charger. So what is the value discipline in this? Is it a differentiated product? Is it an operationally competent product? Is it a customer responsive product? When you look at this, you will find that it is probably the best product because it is high on product differentiation, it is high on operational excellence, and it is on customer intimacy, a very effective product. Therefore, you are getting a best product at a best possible total cost, that means least cost, and is the best total solution. And the actual leadership value of the product is much more wider, broader than the threshold value that is expected. So the key features for the product will be energy conversion efficiency and ease of use and the power storage capability. Because this will be removable, the customers have a choice to use it as a normal solar power bank by removing the back case. But to make this component and the product profile work, there is need for close relationship with the vendors to ensure that the components are made in modular fashion to meet the needs of several types of solar chargers. As with other projects, we have a business model canvas which gives the key partners, key activities, value proposition, customer relationships, customer segments, channels, cost structure, and revenue streams. If you look at the key partners, it comprises the ecosystem, the manufacturers of raw materials, suppliers of components, vendors, distributors, logistic partners, and investors. And what are the key activities? Designing, assembling, R&D, marketing, post-sales support. And the value proposition to the marketplace, delivery of a portable and ergonomic solar mobile charging case with the capability to charge continuously and store power at an affordable cost. The key customer relationships are acquired through social media, word of mouth, referrals, and advertisements, and they will be retained through customer service and upgradation, besides the functioning of the product itself. The product will be sold through omni-channel network, online retailers, offline retail stores, website, social media. Who will be the customers for this kind of product? Definitely students and young professionals who want to experiment everything new. Middle income group which would like to reduce the use of an adapter and the costs associated with that. Tech savvy and environment conscious personnel, travelers, NGOs and corporates, and almost everybody who is going to stay or who is going to transit through a power shortage area. The cost structure for the product is defined by the raw material costs, transportation costs, conversion costs in manufacturing facilities, salaries, partner commissions, operational costs, and marketing costs. And how do you have the metrics? We have to have metrics in terms of the key resources, employees, manufacturing efficiency, machinery efficiency, that is OEE, and the warehousing capability. The revenue streams come from sale of product, investment streams, angel investors, venture capitalists, incubation centers, loans. While the sales of the product will be the actual sales from the product, the investment streams could be seen as inflows into the project to support the capital expenditure. These come from various types of investors. This is the overall business model canvas. What would be the marketing strategy? We need to have a product vision. We need to have a target market. We need to position product properly, and we also need to differentiate the product. So vision is very much specified in the earlier slides, and it is a portable ergonomic solar mobile charging case with capability to charge continuously and store power at an affordable cost, a combination of sustainability and quality. And the target market is defined in terms of a young and middle-aged group belonging to middle income group who are tech savvy and environmentally aware. The positioning will be in terms of an innovative, creative, lightweight, environment friendly, and a more portable version of a power bank which has the capability to charge continuously. Product differentiation is in terms of a more affordable and effective product in the form of a back case with a removable solar module, allowing customers to use it with multiple mobile cases and having an additional capability to get charged under artificial light, though it would take some extra time compared to charging under solar light. What is the marketing plan? You need to have the product defined and optically illustrated in the marketplace. Price will be a penetration pricing strategy. The team has estimated that At 1150 rupees per unit, the startup would be able to make a profit margin of 250 rupees, which is a good price and a good margin, about 20% margin. The distribution channel will be omni-channel distribution network comprising of online, offline, and various other digital retail stores. Promotion will be flash sale model so that the demand can be generated, initially asking for public attention. Thereafter, promotional schemes which keep continuously engaging the younger population through social media and schemes, and also focusing on NGOs because of the environmental friendly nature of this product. Will there be price elasticity? Yes. Therefore, a penetration pricing has been arrived at of rupees 1150, so that it would be more economical compared to a power bank and would be seen as an affordable back case. As we are aware, even a normal back case costs anywhere between 1000 rupees to 2000 rupees. So having a solar power charger at the price of 1150 is a winner for the startup. The product will initially be made available only in the Indian market, and at a later stage will be extended to global markets. The distribution channel again initially will be online retailers, and eventually the product will be made available in retail stores such as Chroma, Reliance Digital, which also have very powerful online marketing channels. Promotion, flash sales model, lot of advertising, providing discounts and incentives to large cell phone dealers for purchasing the product in bulk, alliances with major cell phone manufacturers to promote it as an authorized add-on, marketing the product to NGOs and rural marketers who may carry the information to customers as donations or at a reduced rate, significant promotion by presence in these science fairs, demonstrating the product at the school and college levels, sponsorship of college fairs, demonstrations to customers in person about the potential of harnessing energy from the sun, and participation in the startup award programs that are initiated by the Startup India platform of the Government of India. The human resource strategy, the project will start with a number of staff that are minimum, and then this organization will be structured and calibrated based on the in-house and outsourcing mix. The co-founders will lead the organization. This is the typical organization chart, which is functional organization that is proposed by the enterprise. The operation strategy, the team said that they would establish a small-scale semi-automated manufacturing unit in Sri City near Andhra Pradesh, making it accessible to the vendors and other logistical operations. They have planned to operate the plant with a starting utilization of 35 to 40% to be able to produce around 30,000 units per year, which is around 1% of the total power bank sales per year in India, which is a very, very modest number to switch from power bank to this solar charger, and working a maximum of 20 people on the job. Gradually, this number will increase year over year with increasing sales, and the organization also will expand. There will be regular market analysis to plan the production. Idea is to plan a just-in-time manufacturing strategy with minimal inventory, constant communication between operations and supplier staff to update them with inventory levels, quality requirements, etc. And payable period and receivable periods will be monitored in such a way that there is a positive cash flow at all times to pay the suppliers. The strategy to raise finance is in terms of an overall budget of 2.6 crores, which the company will require according to the team, and that is up to the pre-commercialization stage. This will be met with the help of grants, angel investors, and government loan schemes. The team is upbeat about collecting this 2.6 crores of risk capital from these three sources because it believes that it is coming up with an environmentally conscious product and a clean energy product. Start with the ideation phase will be funded through own and family friend savings. In the prototyping phase, incubators and angel funding will be aimed at for 1 crore of rupees. Higher funding is aimed at in the pre-commercialization phase for an additional 1 crore. And with grants and Series A fundraising, venture capitalists are expected to chip in with about 4 crores of rupees. That is the aim. But the first 3 phases are expected to cost about 2.6 crores and then supplemented based on the commercialization objectives that the company has. So whom should we approach? Every startup founder must analyze the potential investors that are available in the marketplace, and we should also look at investors who are focused on the nature of the product that you are manufacturing. Some investors like retail products, some investors like technology platforms, some investors like social entrepreneurship, some investors like clean energy. So you must look at the investor profiles and then decide who would be the right investors to make a pitch to. So Clean Energy International Incubation Center, a NASSCOM initiative for 10,000 startups, a business incubator from IIT Bombay called Sign, National Network of Angel Investors, Infuse Ventures, and a particular co-founder, as well as Abu Dhabi Investment Authority, which is investing aggressively in clean energy projects, and GIC, which has invested in another green energy project such as Greenco Energy Holdings. These are the kinds of companies which the team has identified for approaching with a pitch deck. Investments that are done by different companies in the solar industry are studied in detail so that the appropriate investors for this project could be identified. And the key investors in renewable energy projects have also been studied, again with the view to get at the right kind of investor profile. A 5-year business plan has been drawn up, which has 3 components: technology and features, which have been discussed earlier; marketing and sales, again, which have been discussed in terms of the 4 Ps; and the financial targets in terms of revenue and profit profiles. With this 5-year business plan, the team has proposed to go to the identified investors and seek funding. There is a sales plan, and therefore there is an income plan based on the costs. There is a cash flow statement looking at cash flow from operating activities, cash flow from investing activities, and cash flow from financing activities, finally arriving at net cash flow. Balance sheet is drawn up, and the shareholding pattern based on setting up and pre-launch, they decided to give certain stock options to employees, and accordingly the whole capital structure has been formulated. Now, as a conclusion, the startup asked itself, will the product succeed? If so, why will it succeed? The reasons are as follows. Solar industry or clean energy industry is expected to grow at a great pace in the coming few years. The recent initiatives by the Government of India to promote the manufacturing and usage of solar powered devices will be a huge boost. The current device with its features will satisfy the customer needs and ensure that it is a better product than a power bank. With its high energy conversion efficiency, power storage capability, and the ability to even work under artificial light, the product will be superior to the products that are currently available. Since it is targeted at specific customer groups who extensively use cell phones, the product can give them a different feel and a new look to their cell phone devices. In any case, it is designed as an ergonomic, portable, high efficiency, continuous charging solar charger, mimicking the back case and integrated with the overall architecture of the mobile phone. So the team believe that the product will succeed. Again, as you go through this product flow, the manufacturing flow and the startup conceptualization flow, we need to appreciate the product conceptualization, the project conceptualization, and the prototype development plan for a selection of technology based on a number of technology options, and then converting that into product specifications, then taking that logically to the components that are required, and the sourcing of the components, the make or buy decisions, the manufacturing approach, the overall organizational approach, and the cost and price structures. This is the way in which a product opportunity can be conceptualized as a startup and presented as a total business opportunity. So that is the usefulness of the case study that has been discussed so far. We will meet in the next lecture. Until then, I remain. Thank you.